So in our new topic, we're going to be looking at circular motion, and circular motion is a topic that covers everything that you can think of that moves in a circle. So that could be, in this case, a CD that's going to go around on a CD player, a DVD player, washing machines, it could be space stations, it could be electrons moving around nuclei of atoms, it could be planets moving around the sun. It's anything that's moving in a circle. And the laws of physics that we're going to look at, which cover circular motion, you can apply to any single one of those scenarios. So we're going to be starting with that today. And the first thing we're going to look at is we're going to look at displacement. Now, the things that we've studied so far, when we're talking about linear motion or translational motion, those things we think of displacement as something that we would measure in meters. Okay, so if you're walking down the road, you would cover a certain displacement from A to B, and we would measure it in meters. Okay. Now, that doesn't apply so well to circular motion. So I'm just going to show you the reason why. This is just a CD that I've got off the shelf, coin here. So if I put the coin on here, all right, and our CD is moving around in a circle, like this, okay. And then we compare it to another coin, which might be over here. The CD is still going round the same number of revolutions per second, but obviously this coin here, which is further out with a bigger radius, is going to be travelling many more meters than this one is per second. However, they would both be travelling the same number of circles per second. So there's a little bit of a conflict there. And when we're dealing with circular motion, this idea of the angular displacement becomes important. So our little coin here in the middle, okay, I've just got two coins. So these coins here, they've both got the same number, they're both travelling the same angle every second. The angular displacement is the same, but obviously this one here has got a different like linear displacement. So this idea of angular displacement is something we need to kind of think about, and that's what we're going to have a look at now. So let's draw ourselves a circle. Okay, now there's the centre of our circle, and that's the radius of the circle. Now, an object moving around in a circle, okay, is going to basically sweep out a certain angle, theta, per unit time. And if you go back to our coins, it doesn't matter if the coin was here or whether the coin was right over here, the angle that it sweeps out per second would be exactly the same. And that's what we mean by angular displacement. That angular displacement would be exactly the same. However, the linear displacement would be different. So angular displacement, we could measure an angle in degrees, but we usually measure an angular displacement in something called radians. And this is something that you guys who do A-level maths will be much more familiar with. Okay, so let's go to a definition of what a radian is. So again, go back to a circle. Okay, we've got a line here, that's our radius. Now, as our object moves around, as it moves around the circle, it's going to sweep out an angle. Now, if it sweeps out an angle here, or an arc, which is exactly the same length as the radius, then that angle that it sweeps out is equal to 1 radian. So that's its definition, basically. The 1 radian is the angle swept out when the arc length is the same length as the radius. Okay. Now, in one complete circle, so one circle, that becomes the circumference of the circle. And we know the circumference of the circle is equal to 2 pi of the radiuses, so therefore it's going to be equal to 2 pi radians. So one circle is 360 degrees, so 360 degrees is equal to 2 pi radians. And we can use that as a starting point to convert from angles in degrees to angles in radians. So for example, if you had 50 degrees, if you wanted to convert that into radians, what you would do is say, okay, so 360 degrees is 2 pi radians, so 1 degree is going to be 2 pi divided by 360 radians. So therefore 50 degrees will be that 2 pi divided by 360 times by 50. Okay, so you can convert from degrees to radians in that way. If you want to go the other way, if you want to convert from radians into degrees, then we can do exactly the same thing. 2 pi radians is equal to 360 degrees. So 1 radian is equal to 360 degrees divided by 2 pi. Remember, 2 pi is just a number. So if you've got, say, I don't know, you wanted to work out what 2.5 radians is in degree, is equal to 360 degrees divided by 2 pi times by 2.5. So that's how you convert between the two. But again, angular displacement is something that we use in circular motion to take the place of linear motion having meters as a displacement. We would have angles, and we tend to, with circular motion, use the radian as our unit of choice.